Imagine a playground where the fun never stops, yet everything stays perfectly balanced. That is the magic of chemical equilibrium. Welcome to LatChem class. Today we are going to be talking about chemical equilibrium. Looking at the seesaw, it seems like nothing is moving, but in the world of atom, equilibrium is dynamic, meaning they move. It isn't about standing still, it is about a perfectly matched puzzle where forward reaction and reverse reaction happens at the same speed. The seesaw is an example of a static equilibrium where no movement and everything is completely at rest. While in a dynamic equilibrium, there is a movement of particles in opposite direction. Example, evaporation and condensation. Evaporation occurs when a liquid changes to gas, while condensation is when a gas changes back to liquid. In a closed system, both happens at the same time. When the rate of evaporation equals the rate of condensation, a dynamic equilibrium is formed. In a simple words, liquid turns to gas and gas turns back to liquid at the same rate. No overall change is observed. Next, we are going to be talking about the properties of system in the state of chemical equilibrium. Chemical equilibrium is dynamic in nature, meaning there's a movement of particles towards forward direction and also reverse direction. 2. Equal reaction rate. The rate of forward reaction is equal to the rate of backward reaction. 3. The concentration of reactant is equal to the concentration of products. Since the system is in a closed system, no substance is removed or introduced into the system. 4. It occurs in a closed system. A chemical equilibrium will not be reached if the system is opened. So, chemical equilibrium occurs in a closed system. 5. No visible change is observed. System appears stable even though the particles are moving. 6. Equilibrium can be achieved from either reactant to product or product to reactant, meaning the chemical equilibrium can be approached from any point, either from forward to backward or backward to forward. Dynamic equilibrium only happens in a reversible reaction, where forward and backward reaction continue at the same rate. In a more simpler term, no reversibility, no equilibrium. Balance achieved, but can it be shifted? What happens when we add more reactant into the system, increase the temperature, or apply pressure? Does the equilibrium stay the same or fight back? See you in the next lesson. Bye.